Alrighty, so this is approximating or estimating values between perfect squares. So now instead of seeing absolute perfect squares like these here, you're going to start seeing things that don't necessarily fall as an exact perfect square. But in order to estimate these values, you need to know your perfect squares, which is why I've listed these all out. So we have this double number line here. So looking at this double number line, you can see that 2 squared is equal to 4, 3 squared is equal to 9, 4 squared is equal to 16. So it's going to be really helpful to know all of these, or at least to write them down in order to approximate these values. So for our first example, we have find the square root of 78. So we know that square root of 78 is not a perfect square. So the first thing we want to do is we want to look at what two perfect squares it falls between. So looking here, I see that 78 is going to fall between the squares of 64 and 81. Looking here, 78 would fall in between those. So then the next thing that we need to do is we need to determine, is it closer to 64 or is it closer to 81? And I know that it is closer to 81, which means that its square is going to fall between 8, it's going to be greater than 8, and 9. So it's going to fall between 8 and 9, somewhere in there. And because it's closer to 81, that means it's going to be closer to 9, which means it's going to be above 8.5 or 8.5. So because it's closer, it's going to be above 8.5 or greater than 8.5. And so then directly between, we'd have 64 to 81. It's going to be about 8.7 because it's close to 9, it's above 8.5, so it would be about 8.7. Okay, these squiggly equals means about. It means it's not exactly equal to, but that's our guess. So another example here, we have find the square root of 5. 5 is not a perfect square, so if we want to approximate, we know it's between 4 and 9. And if we're looking, is it closer to 4 or is it closer to 9? We know it's closer to 4, which means that its square root values are going to be between 2 and 3 because its square is between 4 and 9. And because it's closer to 4, that means it's going to be closer to 2. So we're going to guess about 2.1 because it's close to 2. Okay. Next example here, we have approximate the value of the square root of 200. Again, 200 is not a perfect square, so we're going to find the two perfect squares that falls between. It falls between 196 and 225. So the next thing we want to do is determine, is it closer to 196 or is 200 closer to 225? It is closer to 196, and because 200 falls between 196 and 225, we know that its square is going to fall somewhere between 14 and 15. And because it is closer to 196, that means that its square is going to be closer to 14. And it's going to be less than 14.5 because it is closer to 14. So we're going to say it's going to be about 14.2, maybe 14.3. And so that's about where this one falls. In our next example here, we have approximate the value of the square root of 45. The square root, let's see, 45 is not a perfect square, but it does fall between the perfect squares of 36 and 49. And we want to determine, is it closer to 36 or is it closer to 49? It is closer to 49. And so we know that its square root is going to fall because it falls between 36 and 49. It's going to fall somewhere between 6 and 7. And we're looking, 45 is closer to 49, which means that square is going to be closer to 7, which means it's going to be above 6.5. So we're going to go about 6.7, 6 and 7/10 is about where that would fall. And for our last example here, we have approximate the value of the square root of 136. 136 is not a perfect square, but it does fall between two perfect squares of 121 and 144, which means that its square is going to fall somewhere between 11 and 12. And so the next thing we need to determine is 136 closer to 121 or is 136 closer to 144? It is closer to 144, but not by a lot, but it is. So we know that it's going to be closer to 12, which means it's going to be above 11 and a half. So I'm going to go about 11.7 is about where the square of 136 is.